Okay, probability of binomial distribution. So they've given you this formula here. It's very large. It says the probability of said event is n choose x, so essentially our number of outcomes and successful outcomes or successful trials. That's what our n and x stand for. P stands for success, and then we put it to the power of how many successful trials in a row we need to get. And Q stands for 1 minus P, or failures. So we know that P plus Q must equal 1. These are percentages, okay? So like, you know, for the 60% chance of success, then we have a 40% chance of failure. And the probability of the number of outcomes minus those successful trials. So how many failure trials are acceptable in here? And this is our Bernoulli's theorem. They've given us a question about a young lady telephone. She moved areas, okay? And what they've said is that she's been given a 466 number, and then there are 4 numbers after that. And they want to know, calculate the probability distribution for the number of these prime digits in Tan's new tel. Tan's favorite numbers are the prime. Okay, so her favorite numbers are the prime numbers. So Tan likes prime numbers. 1 is not a prime number, which is something we need to know. Okay. But the other prime numbers are her favorite numbers, which happen to be 2, 3, 5, and 7. So they want to know the probability that all of these numbers will be her favorite numbers. So the probabilities of, you know, these 4 being at least 1 to 2, 3 to 5, and 7, or they could all be that. So what we got to figure out here, what are the options? How many options are there really in this? Well, we go from 0 to 9 with a phone number, right? Which means there's actually 10 options, right? And we do that 4 times. So we're going to figure this out 2 different ways. In other words, because there are 10 options, she has
4 numbers.
Exactly. So she has a 4 in 10 chance of success. In other words, that's our p-value, 4 in 10 chance, okay?
I'm not getting it 6.
That's right, which means our Q would be a 6 in 10 probability of not getting that value. Okay, so what we're going to have to do is we're going to have to figure out her total expression here when we go through it. Now in this question, there's the different number of trials. Prime digits, and then what's the expected number of prime digits? Okay. If we take a look at these probabilities, essentially what we have here, and we'll put it into the binomial distribution in a moment, that probability, we're going to actually have to put these together in order to figure it out. So I'm just going to jump at the probability distribution. Okay, so if you recall, what we said is we wanted all 4 to be her favorite numbers, all 4 of these digits, right? Well, in other words, there's going to be 4 digits, and we want all 4 of them to be successful. Okay? We know that we have to multiply by our p to the power of x, and by, sorry, that should be q, from Bernoulli's theorem, n minus x in this case, right? And this is our n, and this is our x, number of trials. Well, we're doing 4 choose 4. Our probability of success is 40%, and we want all 4 of them to be successful, which means we have 60% chance of failure, and we don't want any of them to be unsuccessful, okay? So what that'll happen is we're going to get 4 choose 4. Do you know what that value is going to be?
1.
I think it's 1, yes. And we have 0.6 to the power of 0. Do you know what that's going to be?
0.
That's not 0, actually. Power of 1 is always 1.
1.
Yeah. So this will become 1 times 0.4 to the power of 4 times 1 again. So in other words, we really just have 0.4 to the power of 4, which is going to equal what?
0.64.
4 to the power of 4?
Or 0.0.
Yeah, 0.0256. In other words, being roughly a 2.56% chance of all 4 of those numbers being the same. Now let's think of this logically. The reason I rewrote this down here, okay, with these numbers. Well, in other words, she had a 4 in 10 chance of the first one being that, right? Multiplied by, okay, think of it like a tree diagram. Well, if she has 10 options, 4 of them being good, once she chooses those 4 options being good, she then has another 10 chances and 4 of those being good. In which case, this is like fundamental counting principle, we multiply these values. So we have a 4 times 10 again, times 4 by 10, times 4 by 10, right? That one's pretty straightforward. We put it into Bernoulli's binomial distribution formula there, but really we could have logically thought about this. We need this to be a prime number, so she has a 4 in 10 chance. And then once that becomes a prime number, she has a 4 in 10 chance of the next one being that. So these all being consecutive, right? So what are the probabilities? Well, essentially it's 4 over 10 4 times, which gives you a 2.5% chance. Okay, does that one make sense? Yeah. So that's applying the theory to that telephone number question.